We're going to move into our next panel discussion now, which is going to focus on yet another critical technology that we've heard mentioned several times today, and that's the role of advanced nuclear and nuclear systems. To help us learn more about the state of this technology and where it can be deployed to support the clean energy transition, I'm pleased to introduce our moderator for this group and one of our leaders and passionate advocates for the role of nuclear, and that's Ralph Izzo, Chairman, President, and CEO of Public Service Enterprise Group. Ralph has got a PhD in nuclear engineering, and which makes him the perfect person to lead a discussion that we're going to have today with two folks, Greg Boerschig, the Vice President of the Clinch River New Nuclear Project at TVA, and also Ryan Umstattd, the Vice President, Product Development at Zap Energy, which is looking at fusion energy. So I'd invite them all to come up, and Ralph, please take it away until you come up, and please help me introduce and join and welcome our panelists.
Great, thanks, Eric. And so Eric already has done the introductions, although you did say that I was the CEO, soon to be former CEO and chairman of PSEG.
I'll leave that to you.
But we'll leave it there. And I'm delighted to be joined today by Greg Boerschig and Ryan from Zap Energy. We're going to talk about two separate nuclear technologies here. Ryan is going to talk to us about fusion energy research, which those of you who are in the audience are probably aware is the exact opposite of fission, which we will have Greg talk to us about in terms of the future of fission. So it appears that all elements in nature like to be sort of medium-sized. So Ryan is good at taking things that are a little bit lighter than they want to be and putting them together. And Greg is really good at taking things that are a little bit heavier than they want to be and splitting them apart. Ryan, we're going to start with you. Could you just give us a little bit of an introduction to the world of fusion? You and I had a pleasant chat in the back about kink modes and sausage modes and ballooning modes and tokamaks, but we'll give them a little bit of an exam on magneto hydrodynamics at the end of this presentation. But for now, we'll maybe give the business person's perspective on what we can expect from fusion in the future.
Sure. Thanks, Ralph. Zap Energy was founded a few years ago to develop and then commercialize fusion power, which is basically firm, on demand, safe and sustainable. Right? We've heard from other speakers already this afternoon about that need for on-demand, firm power and how it's going to continue. But as Ralph mentioned, fusion energy basically takes very light elements. Our fuel stream is essentially isotopes of hydrogen, right? And it's readily available. Deuterium, which is one isotope, is readily available from seawater and can be extracted relatively easily. The other isotope that we use is called tritium. It's got an extra neutron hanging on it, and for that we actually breed that from lithium, again, another highly available raw material. But this fusion energy comes out when you basically compress and confine this plasma. That's the true challenge of how do you get fusion energy, is how do you compress and confine a plasma long enough to get that reaction to take place. Traditionally, it's been either really large magnets or very inefficient, very expensive lasers. Zap Energy uses neither of those. We are an approach that makes use of a historical approach called the Z-pinch, but those were typically getting ripped apart by some of the instabilities that would naturally grow whenever you tried to push current through a Z-pinch. So we found a way to stabilize that Z-pinch, make it last longer so that we can basically get to the temperatures and densities one needs to get fusion reactions coming out. And it's going to be exciting here in the next few years with Zap Energy and all the other private players that are in the field right now.
So Greg, I promise we're going to get to fission. Now, I am going to discipline myself in my enthusiasm for fusion, but as Ryan knows, that this is something that I considered during my graduate study days. The other part that we may want to just share, Ryan, is some of the issues and challenges associated with confining the plasma, right? I mean, that appears to be the number one challenge just in terms of fusion progressing. How do you do that?
Absolutely. So the Z-pinch actually is elegant in its simplicity. For those of you that may have had to struggle like I did through electromagnetics course back in school, when you flow a current through something, you create a magnetic field that curls around that current flow. The charged particles moving in that are squeezed by that magnetic field. So the way that Zap Energy heats and confines this plasma is by that self-magnetic field of pushing a current through this plasma. The plasma is a charged gas, and you can flow lots of current through it. It squeezes down really hard, and that starts to rip the plasma apart, unless you do something like our innovation, which is introduce sheared flow on the outside. Basically, the plasma that's in the middle is kind of like driving down the freeway, and it's got other lanes of traffic that are going by too fast for it to get out of its lane. And that's how we prevent this instability from ripping the plasma apart. So we do use a magnetic field, but it's a self-induced one. We don't have to build a big magnet that sits around the plasma like you might see with a tilt magnet.
So Greg, in the realm of somewhat more conventional, TVA is undertaking a very exciting initiative to advance nuclear power. And I'm sure everyone here knows that while nuclear is currently responsible for 20% of the nation's electricity, it's responsible for, I believe, 50% of our carbon-free energy. In New Jersey, that number is amplified, where 40% of the state's power and 90% of it's carbon-free. And there are some people like myself who believe if we're going to have any chance of meeting the nation's carbon targets, existing nuclear and new nuclear have to play an important role. And there's going to be a lot of eyes on folks at TVA because clearly the industry has not had the best record in delivering new nuclear on schedule and on budget. And so there's many of us rooting for you. But you want to tell us a little bit about what the plans are at TVA?
Sure. Well, TVA has had a program in place to review advanced nuclear for about 10 years. And through that program, we were able to secure an NRC-approved early site permit at the Clinch River site in Oak Ridge, Tennessee. That early site permit will allow up to 800 megawatts of advanced nuclear technology. The early site permit is not, technology specific. The TVA Board of Directors has authorized up to $200 million for exploring advanced nuclear and site additional siting for advanced nuclear locations. And that's consistent with TVA's strategic plan that's available publicly. The small modular reactors program that's split up into two sections. One is a program side that's continuing to look at other advanced technologies, and then the project side, which is focused on the Clinch River project. This project right now is in the early stages, but will play a big role in TVA meeting its decarbonization goals.
So Greg, can you tell us a little bit about there's a range of technologies that are available, right? Here in the U.S., Canada has a different approach. And so we have, conventional power, nuclear power today is about typically 1,100 megawatt plant. Once upon a time, we thought 1,600 megawatts would be the way to go. And I guess most SMRs are more in the couple hundred megawatt range. And then we have different fuel cycles, molten salt, and then we have even people up in New Brunswick working on sort of waste minimization. I think the Moltec project is doing it. How do you get your arms around all these different options that are ready for demonstration today? Are there regulatory limitations that are in the way or that can help?
Yeah, not so much regulatory limitation, but really for us, our focus was on the first-of-a-kind elements of the technology. Of course, we looked at all the things that you would look at for siting a plant, the megawatts, the thermal efficiency, but we also focused on the simplicity of the design and the impact that will have on the design, licensing, and construction, but narrowing in on those first-of-a-kind elements and looking at the various risks that are associated with those. And then by looking at the risk, it's really about a selection process that manages the risks, but also identifying a technology that's the right application for the fleet.
So I want to come back to this in a second, but if I may, I just want to go back to Ryan for a moment. So Ryan, again, not to harp on my ancient history, but back then, DOE was our funding source for fusion energy research, right? Because it was not an inexpensive proposition. I think you have a fair amount of private funding. And notwithstanding Zap's incredible ingenuity and cleverness in terms of your technology, you're not alone in the fusion community that's getting private funding. What do you think is driving that? I mean, this is not a time frame that most investors are comfortable with. Can you say more about the commercial applications and the investment horizons that you think people are trusting you for?
Sure. No, I think that it is getting better and better appreciated, the long and steady progress that we've made in getting to the point where fusion is really close to sort of its kitty hawk moment, so to speak. If you look at the key parameter that all fusion has to achieve, it's this triple product of density, temperature, and time. If you can hold plasma density at a certain temperature for long enough time, you can start to get those fusion reactions out, and you need to get lots of those reactions to earn back the energy that you put into the plasma. Well, if you look at the progress of that triple product over time, over many decades, it's actually improved faster than Moore's law. And we're now at that tipping point where we're just about to hit that kitty hawk moment where you get sort of a scientific break-even. And I think that it's the recognition of that that has really started to unlock additional sources of capital, like the private investments that not just Zap Energy, but many of the other fusion startups are able to leverage now. And again, a bonus side effect of that is the exposure to industry and how well that's informing now the fusion development efforts, as in, compared to them being fairly scientific focused and academic focused when they were under national programs. So it's really about now finding the best ways to use both sides in terms of the public dollars and the private dollars, finding ways to combine them, working with national labs and academic institutions where necessary to help industry get this past the kitty hawk moment and get that Delta Airlines built.
So can I encourage you to look into your perfect crystal ball? I mean, there are many companies that talk about what they're going to achieve by 2030, what they're going to achieve by 2050, and what do we need to do to stay below 1.5 degrees C? What's the time frame that you're conditioning potential users and investors for?
Right. We're targeting having fusion energy commercially available by 2030. Now, we know that's an aggressive timeline, and we intend to meet that by building out a pilot, right? And so there are lots of other things that have to go right outside of our direct control for that to be a commercial endeavor, not the least of which is the regulatory environment. But again, we need to take that big swing. It's required right now by the market, by the planet. So we're going to go as fast as we can.
So I'm going to come back to that regulatory environment and government policies in just a moment, but let's go back and talk about the range of different SMR technologies and what one can do. Now, I'm not going to quote them perfectly well, but I have heard some very, very senior people at TVA say that they're not interested in doing this as a one and done, that they really would like to build out a quote-unquote fleet. That may not have been the exact word. In doing so, are you picking a winner prematurely, or will you build out a fleet of several different technologies to see which becomes sort of a best in breed, no pun intended?
Right. Well, as I stated, we do have both a program and a project. So the program side is still evaluating different technologies. From a project standpoint, though, when you look at the risks associated with a small modular reactor and just the economics of it, the first of a kind, it's going to be very difficult for that to be cost effective. So really, the cost effectiveness is in the learnings that goes into the process and the program, so that nth of a kind or the fleet of SMRs, that you have the cost effectiveness there as well. With respect to how we're evaluating the project, we have a detailed set of decision gates that guides our thinking throughout the process. And then we have a detailed scoping, estimating, and planning process that also helps guide how we do the evaluation. So when we look at the economics and the cost effectiveness at each step of the way, we're evaluating both the first-of-a-kind technology and that nth-of-a-kind to make sure that it's effective. And as you said earlier, if we're not going to build a fleet of SMRs, then we're probably not going to build that first one either.
So we've touched upon this subject of stakeholders and other constituents. Let's talk a little bit about government policy and how it's helpful or how it can be even more helpful. Those of us who own and operate nuclear plants in merchant markets have been very interested in the climate provisions of the Build Back Better legislation that failed, and are hopeful that some combination of production tax credits and investment tax credits for carbon-free energy can be realized so that we can meet our goals. Ryan, when I was working in the plasma lab, we were just hoping for regular DOE funding, and that was a little bit, maybe it wasn't a sine wave, but it had a few more cycles to it than we could use. Are there essential policies that you advocate for now, whether it's something as immediate as the Build Back Better or something longer term that you would need from the NRC or from DOE or whatever relevant agency? I don't think there's any regulatory fusion infrastructure even in existence right now, if I'm not mistaken, right?
That's correct. But it has been encouraging this past little over a year now that the Fusion Industry Association, so Zap Energy, we're a member in that Fusion Industry Association. Together, we've come together with the other companies and been working with the NRC through a series of public meetings to start the process of establishing a regulatory framework. The NRC owes back to their commission by the end of this year an options paper describing how they think commercial fusion energy might be regulated. So the process is going, but I think for us, what's crucial here is not just getting the regulatory framework in place, but also, more importantly, regulatory certainty, right? It's not just about the framework, but how long is it going to take, roughly, and how much is it going to cost, right? And so it's not that we need the framework, but even more important than that, we need to have some upper and lower bounds on things. Same thing when it comes to incentivizing innovative energy technology through things like the investment tax credit or production tax credit. It's not enough to say that fusion will be eligible for them. We need that certainty, right? Because we've seen the whiplash that happens when you let those things expire, and I would love to avoid that when fusion energy is ready for its turn.
Okay.
Greg, how about yours?
Well, as you discussed earlier, the technology differences aren't as great, obviously, as in fusion. But one of the things we've done is we've engaged with the U.S. Nuclear Regulatory Commission and the Canadian Nuclear Safety Commission to work together to look for practical reforms to support the advancement of the new nuclear technologies. We've just started with that process, but very encouraged by it. And there are some things that we need to look at practically, not only for the licensing process, such as I said earlier, standardization from our perspective is really the key. So, did I just? Okay.
Are you okay?
Okay.
You didn't say anything bad?
To build multiple reactors through the licensing process, we're really looking for some consistency in that process. So if it's truly a standardized design, really the focus should be the difference that exists for the multiple plants. We're also looking at things, so for example, standard operator licenses. So if you have a standard fleet, we have a plant in Clinch River, and say, for example, a plant outside of Memphis, that we could use, licensed operators at those facilities as well. Also things such as centralizing training and things like that. So a wide suite of things we're working on, and just starting the dialogue to work with the regulators to advance the processes.
Yeah, please.
And on the topic of licensing a design as opposed to a specific site and power plant, that's going to be crucial for fusion energy as well. I mean, I think that our natural size is more like 50 megawatt electric net output. When you think about that, that sounds like it might be feasible to build in a factory and ship to site, right? And take the time scale down from years to months or weeks for getting new power up and running. And so that'll be crucial for us, is if the NRC can come up with an approach that allows us to work the design and understand that it's that particular device that is licensed, and that there's a variety of different site options for it.
So Greg, you triggered a thought that I want to get back to with respect to staffing and talent. It feels like nuclear is enjoying a little bit of a renaissance to me. I mean, I lost track of how many intergovernmental panel reports have been written now, each with heightened and increasing concern over where we're headed. NOAA just recently announced 461 parts per million of carbon in the atmosphere. I remember once upon a time we were trying to keep that below 350. So clearly, as a carbon-free resource, whether it's fusion or fission, that's got to be something that's particularly exciting for a young person coming out of college. I don't know if they would find resistive magnetohydrodynamics something that would be a fun major, and whether or not nuclear engineering is a particularly fun major. What is it like recruiting talent to your particular companies and areas of expertise nowadays?
Well, for us, where we're at in the program, we're really trying to find a lot of experience with the construction and the various phases we're undertaking. So that's a little bit more difficult because it just doesn't exist anymore with the change in demographics. So what we found is that through developing partnerships, not only are you able to share in the risks, but you're able to share in the learnings as well. In terms of talent out of college, we've had good success at TVA regionally, so I don't anticipate that that changing. But for us, as I said, the real challenge is going to be for those experienced workers.
We've had a huge problem in terms of hiring. This is an exciting time right now for Zap Energy and for a lot of the fusion companies. We are a startup, and so when I joined 9 months ago, we were 30 people. We're 60 now, and we need to double again within the next year. What I find really, really exciting is when we've started tapering off on hiring plasma physicists, and instead we're hiring mechanical engineers and thermal experts and electrical engineers who help build a pulse power. So it's a very diverse set of expertise that we now need to bring into the fold to help fusion energy keep the pace that it needs to commercialize. But it has been a real challenge, again, with lots of things going on in this field right now. We're all in a competition for the limited folks that are out there that are ready to jump in to the fusion energy challenge.
Yeah, not surprising, but my goodness, but the holy grail of solar energy, right? I mean, after all, it is what powers the stars in the universe. In the few brief minutes we have, I'm not losing my mind. That's an accurate statement for those of you who are less familiar with fusion. In the few brief minutes we have, just whatever topic you'd like to address. Any closing comments? Greg, we'll start with you since I started with Ryan earlier.
Yeah, I think the value of small modular reactors is very important to TVA. Nuclear has been a big part of the success we've had at reducing our carbon emissions. Watts-Bar Unit 2 coming online and the Browns Ferry uprates was a big part of achieving the 63% reduction in carbon emissions we've had from 2005 to 2020. When we look at the company goals of 70% reduction by 2030 and 80% by 2035, small modular reactor will have a role in that as well. When we go on to the larger aspirations of net carbon-free by 2050, a fleet of SMRs has the potential to play a very significant role. Whether it's SMRs or other advanced nuclear technology, that base load will play a key role.
Thanks, Greg. Ryan?
I think maybe I'll close with just the idea that fusion again is getting really close to that Kitty Hawk moment. From my perspective, this is exactly the right time to interact with more and more potential customers. And as we start to refine sort of our parameters around what we think our fusion power plant is going to be, how well does that resonate with potential customers, right? This is really about making sure that it's not a technology push, but rather a pull from the industry. And so I'd encourage any of you to find me afterwards if you think you have some ideas for what you think a fusion power plant should look like, because we're forming those, but we want to make sure that it works for our customers as well. So I think it's an exciting time to start reaching out to fusion, and we're reaching out to everyone else as well. So.
Well, Greg and Ryan, speaking on my own behalf, and I think on behalf of anybody who cares about the planet and who cares about energy security, thank you both, and really rooting for both of you to make the kind of progress that I'm sure you're anticipating and that we all hope to hear about in the not too distant future. So, Eric, I think I turn it back over to you now. Can we just thank these two panelists? Thank you.